Department of Computer Engineering and Information Technology. Semester 3rd. Subject Computer Graphics. Myself Miss Anita Shirture. Chapter number 3. Overview of Transformation. This chapter is given for 18 marks. Learning outcome of this video. In this video to discuss about the projection. Projections is a technique or a process which is used to transform a 3D object into a 2D plane. So in this video we understand about the projection. Objective about this topic: to understand basic convention for object transformation in 3D, to understand other transformation like a reflection, shear, and to understand the basic transformation in 3D including translation, rotation, and scaling. These are also in previous video we have discussed about the 2D transformation. The transformations is a process of modifying and repositioning the existing graphics. 2D transformation take place in a two-dimensional plane. Transformations are held in a changing the position, size, orientation, shape, etc. of the object. The transformation means changing some graphics into the something else by applying rules. When a transformation takes place on a 2D plane, it's called as the 2D transformation. Transformation plays an important role in computer graphics to reposition the graphics on the screen and change their size or orientation. Now, we will discuss about the 3D transformation. Transformations are a fundamental part of the computer graphics. Transformations are the movement of the object in a Cartesian plane. It is the movement of an object from one position to another. Translations is done using the translation vector. These are the three vectors in a 3D instead of two. These vectors are in X, Y. Then, first is the perspective projection. In this perspective projectors, the distance of the project plane from the center of a projection is finite. The object size keeps the changings in a reverse order with a distance. The perspective projector is used to determine the projector lines come together at a single point. The single point is also called the project reference point or center point. In this, object positions are transformed to the view plane along lines that converge to a point called center of projection. And in these lines are not parallel to each other. So, here the center of projections are, and after that the A and B, these are the parallel to the another lines. These lines are not parallel to each other. The A and B's reflections are the A dash and B dash, and A dash and B dash is meet to each others in another center of the projections are there, and so it's called as the perspective projection. The characteristic of perspective projectors is the distance between the object and projection center is finite. In this, it is difficult to define an actual size and shape of the project. The perspective projections has the concept of vanishing points, and vanishing points, that means it can be defined as a point in image plane where all parallel lines are interlinked. The vanishing point is also called as the directing point. And one of the characteristics of a perspective projector is the perspective projections is a realistic but tough to implement. Then the use of vanishing point, it is used in 3D games and graphics editing. It is also used to represent now three-dimensional transformation, that means 3D 3D transformation. When the transformation takes place on a third plane, it is called 3D transformation. Methods for object modeling transformation in 3 dimensions are extended from 2-dimensional methods by including consideration for the z coordinate. It is the movement of an object from one position to another, and the translations is done using a translation vectors. There are the three-dimensional modeling transformation generalize from 2D by including z coordinate. In 2D, the two vectors are included, the x and y, and in 3D, the generalize the three including the z coordinates also. Next is the straightforward for translation and scale rotation more difficult. And homogeneous coordinates, the 4 components are there, and transformation matrix, the 4 by 4 elements. There are 2 types of transformation in 3D. The simple transformation and complex and conjugate transformation. Simple transformations again classified in 3 ways: the translation, rotation and scaling. And complex and conjugate transformation divided into 2 parts: the reflections and sharing. Next is types of parallel projection. There are 2 types of parallel projection. The first is orthographic projection. In the orthographic projections, the projections is a perpendicular to the view plane. Projections lines are parallel to each other and also perpendicular to the plane. It is used to create different views of a given object. The orthographic projections is divided into 2 parts: the multi-view orthographic projections. In multi-view orthographic projections, we can represent the 2-dimensional orthographic image into a 3-dimensional object. The multi-view orthographic projections includes, there are the 3 views. First is, next is 3D point homogeneous coordinate. We don't lose anything. The main advantage is it is easier to compose the translations and the rotation. The rotations of a point in straight line or an entire the image on the screen about a point other than the origin is achieved by the first moving the image until the point of rotation occupies the origin, then performing rotation, then finally moving the image to its original position. The moving of an image from one place to another in a straight line is called as the translation. A translation may be done by adding or subtracting to each point the amount by which the pictures is required to be shifted. Translations of a point by change of coordinate cannot be combined with other transformation by using simple matrix application. The first MCQ type questions is: the types of parallel projections are option A, orthographic projections and the quadric projections, option B, orthographic projections and oblique projections, option C, oblique projections and quadric projection, option D, none of these. And answer is option B, orthographic projections and oblique projection. The second question is: the projections in which the projections plane is allowed to intersect the xy and z axis at a equal distance is option A, isotonic projection, option B. Next is the 3D translations. An object is translated in a 3D dimensional by transforming each of the defining points of the objects. Moving of an object is called translation. In three-dimensional homogeneous coordinates representation, a point is transformed from position P of xyz to P dash is equal to x dash y dash z dash. This can be written as using P dash is equal to T into P. Here, given a translation vector, the tx, ty, and tz. Let's initial coordinates of the object O is equal to x old, y old, and z old. The new coordinates of the object O after the translation x new, y new, and z new. Then translation vector or shift vector is equal to tx, ty, and tz. Figure shows the given a translation vector tx define the distance the x old coordinates has to be moved. Ty defines the distance the old coordinates has to be moved. And tz defines the distance the z. Learning outcome of this video. To discuss about the projection. Projections is a technique or a process which is used to transform a 3D object into a 2D plane. So in this video we understand about the projection. 3D rotation. In general, rotations are specified by a rotations axis and an angle. In 2 dimensions, there is only one choice of a rotation axis that leaves points in the plane. 3D rotations is a process of rotating an object with respect to an angle in a. The easiest rotation axes are those that parallel to the coordinate axis. Positive rotation angles produce the counterclockwise rotations about a coordinate axis. If we are looking along the positive half of the axis toward the coordinate origin. Consider a point object O has to be rotated from one angle to another in a 3D plane. Then initialize. Figure shows the 3D rotations and one point is rotated from one place to another and one another angles also. Then let's say the initial coordinates of the object O. The is equal to x old, y old and z old. The initial angle of the object O with respect to the origin is equal to phi and rotation angle is equal to theta. Then new coordinates of the object O after the rotation x new, y new and z new. In 3 dimensions, there are 3 possible types of rotation: x-axis rotation, y-axis rotation and z-axis rotation. Figure shows the coordinate axis rotation. These are the x, y, z and z is belong to the x. They obtain the rotations around other axes through cyclic permutations of coordinate parameters. Next is the z-axis rotation. This rotation is achieved by using the following rotations equation. The x dash is equal to x into cos theta minus y into sin theta. Y dash is equal to x into sin theta plus y into cos. There are 2 types of transformation in 3D. The simple transformation and complex and conjugate transformation. Simple transformations again classified in 3 ways: the translation, rotation and scaling. And complex and conjugate transformation divided into 2 parts. Next is the y-axis rotation. This rotation is achieved by using the following rotations equations. The z dash is equal to z into cos theta minus x into sin theta. Then x dash is equal to z into sin theta plus x into cos theta and y dash is equal to y. These are the equations for solving the y-axis rotations problems. And now scaling may be used to increase or reduce the size of the object. Scaling subjects the coordinates points of the original object to change. Scaling factor determines whether the object size is to be increased or reduced. If scaling factor is greater than 1, then the object size is increased. If a scaling factor is less than 1, then the object size is reduced. You can change the size of an object using the scaling transformation. In the scaling process, you either expand or compress the dimensions of the object. Scaling can be achieved by multiplying the original coordinate about origin, changes the size of the object and repositions the object relative to the coordinate origin, where Sx is equal to scale factor in the x direction, Sy is equal to scale factor in the y direction, and Sz is equal to scale factor in z. About any fixed point, scaling with respect to any arbitrary fixed point is not as simple as scaling with respect to the origin. The procedure of scaling with respect to an arbitrary fixed point is translate the object so that the fixed point coincides with the origin. Scale the objects with respect to the origin. Use the inverse translation of step 1 to return the object to its original position. Reflections is a kind of rotation where the angle of rotation is 180 degrees. The reflected object is always found on the other side of a mirror. The size of the reflected object is same as the size of the original object. The reflections in a computer graphics is used to emulate the reflective objects like mirrors and shining surfaces. The reflections may be an x-axis, y-axis, z-axis, and also in the planes xy plane, yz plane, and zx plane. Reflection relative to a given axis are reflections about x-axis and y-axis. The types of reflections. There are the three types are using the 3D reflections. The reflections relative to xy plane, reflection relative to yz plane, and reflection relative to yxz plane. The reflection relative to xy plane. This reflections is achieved by using the some equation. The x nu is equal to x old, y nu is equal to y old, and z nu is equal to z old. As well as this reflections is achieved by using the following equations in the yz plane. The matrix for the reflections about a y-axis is the next is the 3D shearing, a transformation that distorts the shape of an object such that the transformed shape appears as if the object were composed of an internal appears as if the object were composed of internal layers that had been caused to slide over each other is called as the shearing. 3D shearing is an ideal technique to change the shape of an existing object in a three-dimensional plane. In a three-dimensional plane, the object size can be changed along x direction, y direction as well as z directions. There are three versions of shearing. The shearing in 2 dimensions, the transformations relative to the x or y axis to produce distortions in the shape of the object. In 3 dimensions, we can also generate the shears relative to the z-axis. Figure shows the before shearing and after shearing. In this, the figure A, the actual objects are put it there, and in B, after shearing, we can imagine this objects in two dimensions way. And the transformations relative to the x or y axis to produce the distortions in the shape of the object. So in the 3D dimension we can also sharing about xy axis. The parameters a and b can be assigned any real values. The effect of this transformation matrix is to alter x and y coordinate values by an amount that is proportional to the z value while leaving the z coordinate unchanged. Boundaries of planes that are perpendicular to the z axis are thus shifted by an amount proportional to the z. An example of the effect of this sharing matrix on a unit cube is shown in figure. For share, thank you.